right? As in, first of all, we cannot factor by grouping, unfortunately, right? So we'd have to P over Q it, which is a little unfortunate, but not that bad. So we'd say, okay, possible factors of P, 1, 2, and 5, right? Possible, and 10, and then, thank you, possible factors of Q plus or minus 1. So P over Q's, I'm going to be lazy right now, are just this, right? Okay, so then from there, I would just test, let's pretend, like I said, don't touch your calculator. So starting with 1, 1, negative 5, 4, 10. Wait, does 1 work? No, okay, so then you go on to negative 1. Now, or we could have done Descartes' little signs anyways. Continuing. Negative 1, add straight down, we get negative 6. Add straight down, we get 10, and then negative 10, 0. Now from here, this is what you should have done. So you should have said, great, x equals negative 1 is a rational solution. But now instead of continuing to test, you should be saying, I now have a quadratic. I took a cubic, divided it by synthetic division, giving me x squared minus 6x plus 10. A lot of you did this. I saw that back group did this correctly. So then they said, okay, now I know for a fact if the quadratic factors, then I can find the other two rational solutions by factoring. If it doesn't, there are no other rational roots. Well, it multiplies to be 10 and adds up to be negative 6. Nothing. So we found all the rational roots, because if we continued to solve the quadratic, it would be irrational or imaginary. All good? Okay, cool. Very good. What we're learning today, and we're going to continue to solve polynomials. So understand, last time what we did was we were only asked about rational solutions. They said find all the possible rational solutions, find any actual rational solutions. So we learned a method, P over Q, to figure out possible rational solutions, and then last time we saw if there was rationals. If not, we stopped. What we're doing today is we're going to continue to solve even if there are not any more rational solutions. So we're going to just solve a polynomial or find all the roots, same thing, of a polynomial, and we're going to use the most appropriate method. So depending on the polynomial, yes, you've got to choose what's the most appropriate method. Then also you have to understand it's called the fundamental theorem of algebra, which is the number of roots will be equal to the largest degree of the polynomial, which we already know that, right? We've talked about that. Okay. So this is the fundamental theorem of algebra. So first of all, let's talk about something. If we wanted to be technical, you can factor any polynomial of degree n to n linear factors. But sometimes those linear factors will have imaginary numbers. So for example, if I said to you though in the future, x squared plus 49 factor, you would not say it, you'd say it doesn't factor, okay? Right? It doesn't factor, technically, right? But if I said to you, I absolutely want you to write that as linear factors, well, yeah, then we could. It just doesn't factor nicely. Does that make sense? So if we factored this technically with linear factors, if I said rewrite this as linear factors, wouldn't I have to subtract 49, square root it, and get plus or minus 7i? And then we'd work backwards, getting these linear factors. Everybody good? Okay. So once again, the essential understanding is that the degree of the polynomial equation tells you how many roots the equation has. So let's look at stuff we've seen before, which we already know all this. Quadratics have two solutions. Look right here. It has two real zeros because it's crossing the x-axis twice, right? One negative real, one positive real, looks like. Everybody good? This quadratic has technically it has one solution, but it has a multiplicity of two, giving me my two solutions. Because it touches, bounces, and goes back up. Everybody understand? So it still has two solutions, and then this would have two imaginary zeros. So basically what this is saying is no matter what, this is going to have, degree 2's have two solutions. So how many solutions do degree 1's have? One. How many solutions do degree 3 have?
3.
And so on. That's literally the fundamental theorem of algebra. It says the highest degree of the polynomial, if the polynomial is set equal to 0, has that many roots. That easy. Everybody understand? Now they call those complex roots. Any roots are complex roots. So note, a complex numbers has this form. Complex numbers have this form. A plus bi. So do you see how this is a complex number?
Yeah.
So that would be considered a complex solution. Do you see how this is technically 4 plus 0i?
Yeah.
So that's actually a complex number. This is a complex number, this is a complex number, and then this is technically 0 plus 6i, that's a complex number. So all numbers are complex numbers. Does everybody get it? Even x is equal to 3 root 2, for example. That's technically 3 root 2 plus 0i. So do you see how basically if I say to you find the complex solutions, I'm just saying solve the polynomial no matter what the solution looks like. Yeah? Okay. All right, let's go to problem number 1. All of my examples are coming off your worksheet. Notice the instructions. This is what's really important. It says, without even so much as looking at a calculator, find all the complex roots of the equation. Once again, complex roots means just solve it and find all of the roots. So today we don't get to stop at rational roots. We need to find every single solution. Now, once again, the fundamental theorem of algebra says we should have how many solutions? 5. So we've got to make sure at our final answer we have 5 solutions. All right, here we go. So let's look. Do we know how to factor this right now by any method? Nope. So we would have to use P over Q. Here we go. It wouldn't group though. There's not 4 terms. So let's list out P over Q. So remember, here's Q, here's P. Factors of P, plus and minus 1, plus and minus 5. Q is plus and minus 1. Not too bad. P over Q is plus and minus 1, plus and minus 5. We divided all P's divided by Q's. Now remember, we're not even supposed to look at a calculator. So now I could use do Descartes' rule of signs, but to be honest, where there's only this many, I'm not going to because that's just, it's just as easy to quickly test some of these. But watch what I would expect. So let's start with 1 and test out 1. Here we go. 1, negative 3, negative 8, negative 8, negative 9, and negative 5. Now on the homework, if you forgot to put in, like let's pretend there was no x to the 4th, you can't forget to put in 0. Yeah, I've had a few people come in and ask me. Good point. So you just can't forget that if you're missing some value, you've got to put in a 0 as a coefficient. Okay, let's go through this pretty quickly here. We're pretty good at this, I'm thinking. Did I mess up? Are you guys getting the same thing as me? Yeah. Going quick. Okay, now looking at this, I'm going to stop because aren't I able to see that definitely it's not a remainder of 0? Yeah. So why continue? That's what we're trying to do here. So instead, I'm just going to go like this. Okay, 1 is definitely not a solution. I'm going to start back over with negative 1. Oops. 1 times negative 1, add straight down. 4, add straight down. 4, add straight down. Sorry. Add straight down. Add straight down, and boom! Now I'm going to go off to the side, and I'm going to make myself what I call a bucket of solutions. I want all your solutions in the same spot. So now we can add our solution x equals negative 1 to the bucket of solutions, okay? Now what I want you to understand, think back to when we were doing this. Don't we know that we just technically factored that then? Because we got a new polynomial. It was x to the 5th. We divided it once, and so we got x to the 4th. Let's write out what we have. X to the 4th minus 4x cubed minus 4x squared minus 4x minus 5. And wasn't it technically that polynomial times x plus 1? If that's a solution, isn't this a factor? So we technically factored this now. Everybody looking. So here's the point of me showing you this. Now what you could do is say, I don't want to keep testing values, and I wouldn't want you to if you could solve by a different method. Do we know how to solve this polynomial? Can we factor by grouping or anything here? We still don't know how to solve, so we're going to still continue with P over Q. However, everybody listen carefully. You are not going to go back and use these coefficients, because wouldn't we rather say, okay, let's continue to factor this, because then if we factor it, won't we go from degree 4? If we divide it, won't we go from degree 4 to degree 3? So let's use these coefficients instead. Does that make sense? So it's smaller. Nope, because that'll be the same. This will have the same solution as this polynomial. So it doesn't matter which one we divide. It's going to have the same solution. Because it is equal to this, right? This is equal to that. So they have the same solutions. So now we're going to use these coefficients here. Let's see if this divides more. So here we go. 1, negative 4, negative 4, negative 4, negative 5. We're not going to do P over Q again. We have our P's over Q's. So let's test out maybe positive 5 with these. Let's see if 5 divides out. Here we go. Drop down 1. Add straight down. 5, add straight down. 5, add straight down. 5, add straight down, and we get 0. So we know 5 is a solution, so I'm going to go over to my bucket of solutions. X equals 5. Now you have to understand what you just did. You just said that this piece factored to b. So we already had our x plus 1, didn't we? Then didn't we now have an x minus 5? Because didn't this piece factor to be x minus 5 times this new polynomial here? So this is x to the degree 4 divided by something linear is degree 3, right? X cubed plus x squared plus x plus 1. Is everybody following me? So once again, that piece that I just circled became this times this. Here we go. X cubed plus x squared plus x plus 1. And then we had our x minus 5. That's what the circle thing factored to be. Is anyone confused? Okay. So now you say to yourself, awesome, I have this all factored. Let's continue to factor what we can. We're done here, we're done here. But look at this. What method could we factor this by? Grouping. That would be way good. Here we go. So now we'll pull out x squared. Divide by x squared, divide by x squared. Left is x plus 1. Pull out 1. Divide by 1, divide by 1. Left is x plus 1. So it did factor by grouping because my safe haven's the same. So don't I pull it out? Pull out x plus 1. So then it divides out, and left is x squared plus 1. So that piece became that. So we technically had this, x plus 1. From that, we have an x minus 5. And then that middle piece became this. And now can't I solve it? Now that I've got it factored out completely. Okay, let's solve. Which some of these we've already solved, but let's just write out our solutions here. Negative 1, am I right or am I right? Yep, negative 1, so we could write negative 1 with a multiplicity of 2. Then solving this one, we would go x squared plus 1 equals 0, subtract 1. Square root of negative 1. Plus and minus I, right? And then 5. So now we have, let's count. We better have 5 solutions since it was degree 5. 1, 2, 3, 4, 5. So do you see how I divided it twice? And that made it something that we could then factor by grouping. So, all good? So we got x equal to 1 with a multiplicity of 2. X equals 5, and x is equal to I, and x is equal to negative I. And now I know I have all my solutions. You should always check. Degree 5, 5 solutions, I'm good. Okay, very good.
So, how do we write these out?
These are complex roots. Yep, complex roots just mean any root. That's technically a complex number. 5 plus 0i. This is 0 plus I, right? So they are complex roots. Good question. What? Sure. Okay, without using a calculator, find all of the complex roots. Once again, you should use the most appropriate method. So what should we try? Grouping, if possible. That's going to be a lot easier than P over Q, isn't it? Okay, let's try it. Pull out x squared. Left is x minus 2. Pull out positive 4. It's a miracle because it did factor by grouping, so hallelujah, we don't have to use P over Q. That's kind of my last resort, to be honest. Now, once again, technically, this does not factor, correct? However, if I did say write it as a linear factor, then you could, but I'm not. I'm saying solve by factoring or solve. It doesn't factor technically, so let's just solve using the most appropriate method. X equals 2. A lot of you cannot do this correctly in your head. You get them wrong. So don't just square root it right here. Just write it out. X squared plus 4 equals 0. Solve for x. Minus 4. X squared equals negative 4. Square root both sides. X is equal to plus and minus I'm going to go and put all my answers so it's easy for me to see in the bucket of solutions. All good. Not bad, right? Okay, let's go to number 3. Yeah, so now we're just using P over Q to solve completely, where last time we got to stop. And you're right, if we don't have to use P over Q, we don't want to. Yeah, it is a review of everything. That's why it was such an easy day for everybody. Okay, so we did so well on that first test. So shouldn't we try grouping? But I had someone first hour ask why it doesn't work. So let's see why. I'm going to show you. Pull out -1, right? Is my safe haven the same? No, so that's when you say, okay, dang nabbit, factoring by grouping. I mean, dang nabbit, factoring by P over Q, or solving by P over Q. Either one, same thing. There's no other way, there really isn't. That's why we learned it. P over Q, so listing out possible P's over Q's. So factors of P are plus and minus 1, plus and minus 2, aren't we? And then factors of Q are plus and minus 1, so won't that be P over Q here? Is that going to bug anyone skipping that step? Okay. Now, once again, do not touch the calculator. So let's see here. Well, we could test whatever. Which one do you want to test first? If you want to look at the cards rule of signs, you can, but really, there's not that many. Let's try -2. Okay, negatives. I like the idea. Let's try -2 first. Sure. 1, 1, -1, 2. Here we go. Add straight down. Boom. So we go off to the side and say x equals -2 in the bucket of solution. Now you should not keep testing. I would expect you to now use a better method. You'd say I took a cubic, I divided it once. Now I want you to understand. Now technically this factored to be x plus 2, didn't it? Times, right here we got x squared, didn't we? Minus x plus 1. So if I said to you factor, you're factoring by P over Q technically right now. Now I can solve it. You say, does this factor, what multiplies to be 1 and adds up to be -1? Nothing. So we would have to continue to solve by quadratic formula. Oh my gosh. That was so dramatic. All right, here we go. X equals -b, so 1 plus and minus the square root. It was so sad that some of you did this on your test, got this far, and then got the quadratic formula wrong. Especially because I've given you so many step-by-step instructions. B squared minus 4 times A times C, all over 2 times A. So you would type it into your calculator, just this. Okay, let's just think about it then. 1 squared minus 4. -3, right? But that's where you would type it in your calculator because I think most of you would mess up that. Okay, -3 all over 2. Then isn't this where we go off to the side and break it down? Well, it doesn't break down, but we do pull out an I. So I'm going to go back up and put it in my bucket of solutions. So we have x is equal to 1 plus and minus I root 3 all over 2. Now, once again, the fundamental theorem of algebra says we should have 3 solutions. And we do. So we're good. We've listed them all. Okay, ready, set, go. Do 1 through 6. Yes, okay. Okay, so let's solve this one the easy way. Let's pull out a 5x. So then left would be x squared minus 1. Now I like you to factor if possible. So let's see. What multiplies to be -1 and adds up to be 0. -1 times 1. So doesn't this piece continue to factor? Because what if I would have said just factor? So it's good practice. Because in the next unit, we'll be factoring every single lesson. Okay, now we factored it down to 3 linear factors. So x equals, what here? 0, 1. You're right. Let's get some confidence in those voices. That's right, yes. That's just y equals, right? Function. So we're solving the function. Is that what, find the zeros, didn't we do that? Okay. Go to number 9. I should not be doing P over Q because there's not even a constant here, but you shouldn't be doing that anyways. What should we always do if possible? Yep, pull out 2x, so then divide by 2x and so on. So then left is 6x squared minus x minus 1. And once again, I would want you to factor it because I just do. I promise you I'm quicker than you. We're quicker at factoring the quadratic formula. Well, multiplies by negative 6 adds up to negative 1, negative 3 times 2, right? Even though, do not quick factor, long factor. Even so, it is quicker than quadratic formula. Watch. 6x squared minus 3x plus 2x minus 1. Parentheses by grouping. I'm trying to show you how fast it is. Okay, 3x plus 1, and then 2x minus 1. That was quicker than quadratic formula, I'm telling ya. We factored this now completely, so now we can we have 3 linear factors, we can set them equal to 0. One more thing to notice is I should have pointed out on the last one, the whole point of doing this lesson is to say, the fundamental theorem of algebra says, since it's degree 3, that I should have 3 solutions. So you should always be checking. Okay, here we go. X equals 0. A lot of you mess this up doing it in your head. You say 1/3. Yep, x equals negative 1/3, and x equals. The fundamental theorem of algebra says we should have 3 solutions, doesn't it, on this one? Okay, cool. Number 12, I think you guys get the picture in this section, so I'm not going to continue. Ready, set, go, 7 through 12. So let's go to 13, and let's read the directions very carefully. That's one thing we want to do here, because we don't want to do extra stuff if we don't have to. So it says, for each equation, state the number of complex roots. Now, it didn't say find the complex roots. That would mean solve it completely. This one says, how many complex roots does this have? 2. It's the highest degree. So we would show our work really nice and pretty. So the number of complex, I'm going to write number of complex roots, was 2, the highest degree. That's the fundamental theorem of algebra. Now read the next part. The possible number of real roots. That's Descartes' rule of sign. So there are positive real roots and there are negative real roots. Let's list out how many possible positive and negative. So change the sign. Positive to positive, nope. Positive to positive, no. We know for a fact it is never crossing the x-axis in the positive direction. Positive x-axis. Let's test negative. That would be plugging in a negative, so that would be 2 negative x squared plus 5 times negative x plus 3, so that would be 2x squared still, minus 5x plus 3. So yep, 1, 2. So we have 2 or 0. So we don't know for sure, but we're just listing out possibilities. So isn't it true that if we have 0 and 0, that would mean 0 positive, 0 negative, so there could be 0 real roots? Which makes sense. Think about a quadratic that never crosses the x-axis. Or couldn't there be 0 positive and 2 negative? Think of a quadratic that crosses twice in the negative zone. Okay, cool. That's good. Now it says, and the possible rational roots. We have to list out the P over Q. It wants to know what are the possible rational roots. So here we go. Factors of P, plus and minus 1, plus and minus 3. Factors of Q, plus and minus 1, plus and minus 2. So now in our answers, I'm going to do my answers over here and maybe my work over there. So P over Q's rational roots would be 1, 1/2, 3, 3/2. Luckily, it's not asking us to now go find all the rational roots, and it's not asking us to solve all the roots. That's all it's asking for, is possible answers here. And we're done with that problem. Pretty easy, right?
Yep.
Okay, let's do 21. Complex. How many complex roots does this have? Number of complex. 5. Possible positive real roots. Positive to negative. Negative to positive. 1, 2, 3, 4, 5. Wasn't there 5 changes?
Yep.
So in the positive x-axis, it could cross 5 or 3 or, and then negative. Plug in a negative. Once again, I'm going to go do my work over here because I like to have your answers nice and pretty. Plugging in negative x. Okay, so this became negative 4x to the 5th. Does everyone agree? Am I seeing that too fast for everybody? Okay, isn't that positive? So it's still negative here. Negative 5x to the 4th. And then that's negative x cubed. Then look, that's still positive, so that's still negative. Negative x squared. That becomes negative. And then we still have minus 6. So I'm just going to, boom, perfect. That worked out, didn't it? Okay, let's see. Negative, 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 negative. Okay, so 0. And now possible p over q's. Here we go, listing out factors of p. Factors of q, and then I'm going to put my answer on the other side. All possible rational roots. 1, 1/2, 1/4. 2, 2 over 2 is 1, 2/4 is a half. So we have 2, 3, 3/2, 3/4, 6, 6/2 is 3, 6/4 is 3/2. We've got them all listed, and we've answered the question. Really not that bad.
That's all you need.
Yeah. Yeah. Uh-huh. There are 5 possible positives. Oh, and since there's 0 negatives for sure, we can now throw out all those negatives. Good point. Yes, absolutely. Oh, I see what you're saying. Yeah. Well, what if we would have been 4? So what if it was 4 and 1? But we knew it was... Oh, yeah. I see what you're saying. Yeah. You're just putting logic together to say that that's 0. I see what you're saying. Yeah, that's fine. If you can see it, right? Yeah. Okay, I think you guys get the picture. Now, everybody look at number 25. Read the directions, because this is the easiest one I've ever seen on a math assignment. It says, find the number of complex roots. What would my answer be? A, and that's it, right? That's it. Okay, the fundamental theorem of algebra says the number of complex roots will be the highest degree. The answer is 8. Okay, ready? Go for it. Go for it. Yep, on 13 to 24 odds only. That's enough practice. Find all the zeros. That just means find all the complex roots or solve it. So let's solve using the most appropriate method. Shouldn't we try factoring by grouping? So let's factor by grouping. Pull out 2x squared, am I right? So then left is x minus 4. Let's pull out a positive 18 if possible. And voila, it works, luckily. So then we would say, okay, we can pull out x minus 4. Luckily, we could solve by grouping instead of by p over q. Or factoring by p over q technically too. So then from here, I would want you to see if it factors more. Actually, now let's just solve. The easiest way. So when we get x equals 4, you're not at the level that you should just do this in your head, because a lot of you will get it wrong. 2x squared plus 18 equals 0. See, you did it in your head and you got it wrong. Okay. Yes. But you see how easy that is to be so confident and really just do the math? No, that was a great example. I'm really glad you messed that up. Okay. Square root both sides. That's my point. Okay, and then x is equal to plus and minus 3i. Make sure you're using the fundamental theorem of algebra to your advantage. I have 3 solutions. I better have 3, and I do. So I'm good. Next one. This one, dang nabbit, does not factor by grouping. Looks like we are going to have to do p over q. And then Q. Okay, luckily, okay, is anyone going to be mad if I'm lazy and say P over Q is just going to be all that stuff since we're dividing by 1? You're going to be mad? Okay, not mad. Okay, thank you. Okay, so now from here. Now, yes, if it was a test, you guys, you would not, if it was a test and I said no calculator allowed, then you would just start testing values. You could now do your cardinal rule of signs and whatnot, but there's a lot of them. So right now, because I'm trying to hurry, what does it look like it's crossing it? I only will allow 1, though. Like, where should we try? So go ahead and test, is what I'm saying. Type it in and see where it looks like it's crossing, so we know which one to test first. Anywhere? It looks like it might be crossing a -3. Let's test that out then. This is what I would expect though. Okay, so but I would only let you use 1 for this one, and then I would want to see by hand you solve the rest. Okay, so now over here you'd say, okay, so in my bucket O solutions, my favorite saying today, is -3, but this is what I would not want you to do. I wouldn't want you to necessarily keep testing. So don't we technically, if I said factor this, technically you would have an x plus 3, wouldn't you, from that? And then you would have this new quadratic. So that's 4. So we would write out, okay, x squared minus 5x plus 4. This is what I would expect on a test. Now you'd say, okay, cool. So I factor this down. We have our -3. We've already written that solution. Let's see if this factors. Well, multiplies to be 4 adds up to be -5. 1 times 4. Yep. Can't I quick factor it? So x minus 1 and x minus 4. Now, why did I do that? Because up there, on a future thing, like on a future assignment, I might say, factor this, and this would be the only way. So you see why I'm now teaching you to use this idea here. So then we have these 3 factors. 1, 2, 3. So even though we didn't know how to factor it by P over Q, we were able to. So x is equal to 1 and x is equal to 4. That would be like if you were not allowed to touch a calculator. This is how you do it. All good? Okay. Number 33, P over Q. Dang nabbit, isn't it? Okay, you're going to do 33 on your own. But isn't it P over Q?
Yeah.
We don't know any other method, do we? No greatest common factor, not factoring by grouping, it's not quadratic in form, it's not perfect cube. Look at number 41 though. You could do this one by P over Q, but if you did, you would be a sad person. Because what should we really factor this by? U substitution, you're right. So let's rewrite this. This is really 9u squared plus 5u minus 4 if we do a u substitution here. And now we'd say, okay, let's factor the quadratic. What multiplies to be -36 and adds up to be 5, 9 times 4, -4. Then you would not make the tragic mistake of quick factoring. We would drop and break. So we have 9u. Don't accidentally change this to x. That confused some people on the test. So 9u squared plus 9u minus 4u minus 4, factoring by grouping. Pull out 9u, left is u plus 1. Pull out -4, u plus 1. So u plus 1 times 9u minus 4. And then you'd say to yourself, but we're not dealing with u's. Yes, I factored it using a u, but really it's an x squared. So this is really x squared plus 1 times 9x squared minus 4. And now we can continue to solve. Solve for x. Plus or minus I. And then we would have, what should I do first on this one? Add 4, divide by 9. 4 ninths. Next step? Next step. Let's not rationalize. We could, but that would be the hardest way. Okay, but yes, this is what I'm looking for, what Adam says. We should now split it apart. Square root of 4 over square root of 9, which is, you're right, 2/3, which I forgot a plus and minus, didn't I? So we would have x is equal to plus and minus 2/3, and x is equal to plus and minus I. Check. Was it degree 4? Then we're good. We have 4 solutions. Use the most appropriate method. So once again, on this one, the only way to solve is P over Q. All right, that's it. Cross out problem 31. The rest of it is due next time. You still have like 20 minutes. Yep.